Ground shaking, ground rupture, liquefaction and tsunami? How are these scenarios related to earthquake? Hello, Disciples! I am Sir Da Vicente, your science teacher for today. In this episode of Agham Alam Hub, we are going to discuss the different dangers associated to earthquake. We are going to analyze the effects of the different earthquake hazards. In addition, we will also recognize the natural signs of an impending tsunami. Finally, we will reflect on the importance of understanding the different earthquake hazards and their effects. In the next few minutes, we will explore science for another moment. Earthquake is the shaking of the surface of the Earth resulting from a sudden release of energy in the Earth's lithosphere that creates seismic waves. Earthquakes can range in size from those that are so weak that they cannot be felt, to those violent enough to propel objects and people into the air, or wreak destruction across the entire cities. Episode 7 of Agham Alam Hub discusses in detail the nature of earthquakes. Earthquake hazards may be experienced depending on the strength of the seismic activity. There are other factors such as local topography and built features of infrastructures, geologic subsurface, and groundwater, just to name a few. Let us discuss the different earthquake hazards and their effects. Ground shaking is the vibration that we feel when the energy build-up by the application of stress to the lithosphere is released by faulting during an earthquake. Most natural earthquakes are caused by sudden slippage along a fault because there are irregularities on the fault plane. If an earthquake generates a large enough energy, giving enough shaking intensity, infrastructures such as buildings, bridges, and dams may experience severe damage. Furthermore, ground shaking might result in the destabilization of the slope of cliffs and the ground. Piled objects may fall and might bring additional hazards to the individuals nearby. Ground shaking per se cannot harm you if you are in an open field. Harm to individuals may be caused by the inferior design of infrastructure, such as poor constructions or weak foundations. Another hazard and an important effect of earthquake is ground rupture. It occurs when the earthquake movement along a fault breaks the Earth's surface. The lithosphere breaks when its strength is overcome by a large amount of stress applied. This breaking happens in much the same way a piece of rock does when struck hard enough with a hammer. When an earthquake is strong enough, faulting initiated at depths may breach the Earth's surface to form a ground rupture. Faulting tends to occur along zones of weakness, such as old or pre-existing faults, fractures, or along bedding planes, which are contacts between sedimentary rock layers and between different types of rocks. Stresses acting on broken rock masses need only to overcome frictional resistance along these old planes of weakness. The ground rupture length depends on the magnitude of an earthquake. Earthquakes with a magnitude 6.5 or greater are generally strong enough to produce large-scale ground ruptures. Another earthquake hazard is liquefaction. When the ground shakes, some areas, especially those made of wet, fine sand, are subjected to liquefaction. Liquefaction occurs when sediment grains are made to float in groundwater, which causes the soil to lose all its solidity. They can spray mud and sand over an area a few meters across. Liquefaction takes place when loosely packed, waterlogged sediments at or near the ground surface lose their strength in response to strong ground shaking. Liquefaction occurring beneath buildings and other structures can cause major damage during earthquakes. Liquefaction causes some of the most striking ground failures and damages to man-made structures. Damage during liquefaction results from the settlement of the structures into the soil, flow landslides, laterally spreading landslides, and the injection of water and sediments at the surface in the form of sand lows or sand boils, fountains, or even seepage of water that leads to flooding. Let us demonstrate how liquefaction happens through a simple experiment. Fill a container with sand and add enough water so that the lower bottom of the container is covered. We will use this brick to represent a solid structure. Tap the edge of the container continuously to represent an ongoing earthquake and observe what happens. Notice that the ground seems to look stable at the beginning, but as the earthquake occurs, the underground water, which is mixed with the sand, causes the foundation to liquefy, thus destroying the structure. Earthquake-induced landslide is another hazard. Ground shaking due to earthquakes destabilizes cliffs and steep slopes, causing landslides and rock falls as a significant side effect. Heavy rain and unconsolidated or fractured rock are contributing factors. Landslides are caused by earthquakes, both by direct rupture and by sustained shaking of unstable slopes. They can easily destroy buildings in their path, or block roads and railroad lines, or take hilltop homes with them as they tumble. Another earthquake hazard is tsunami. Destructive waves that are generated by earthquakes and other events had been given numerous misleading names in the past. These types of waves are not rare occurrences in Japan. It is no wonder then that the Japanese term tsunami, which means harbor waves, is widely used even if it is also a misnomer. Perhaps a term that reflects both the conceptual and operational sense of the phenomenon would be preferred. Regardless of the origin, all tsunamis are triggered by powerful events that cause sudden displacement of large volume of water. Tsunamis are a series of water waves caused when the seafloor moves vertically during an earthquake. Take note that the horizontal shaking of the seafloor will not trigger a tsunami. Tsunami speeds in the deep ocean have been measured at more than 700 kilometers per hour, comparable to some jet planes. And when tsunamis reach shallow water near the coast, they can reach heights of more than 27 meters. Remember that tsunamis are a series of waves and may start with a gentle withdrawal of water, followed by a very abrupt arriving wave, followed by another withdrawal. Tsunami can cause flooding, coastal erosion, drowning of people, and damage to properties. The safest thing to do if you hear a tsunami is coming is to move to the higher ground away from the beach as quickly as possible. Tsunamis are caused by events near the tsunami sites of origin, but it may also be caused by something that is not local to the tsunami source. It may be triggered by landslide and volcanic eruption or explosion. The most recent destructive tsunami ever recorded in the modern times happened in 2018 in the coastline region of Banten and Lampung, Indonesia, which was devastated by a deadly 3-meter tsunami due to an earthquake induced by a volcanic eruption of Anak Krakatau on the Sunda Strait between the islands of Java and Sumatra. What are the signs of an impending tsunami? We can detect tsunami using our senses. Feel the ground shaking severely or for a long time. Severe ground shaking from local earthquakes may cause tsunamis. See unusual disappearance of water. A tsunami may be preceded by a rapid fall in the sea level as the ocean recedes, exposing reefs, rocks, and fishes on the sea bottom. Hear a loud roaring sound. Abnormal ocean activity, a wall of water, and an approaching tsunami creates a loud roaring sound, similar to that of a train or jet aircraft. We may not prevent an earthquake from happening, but understanding the different earthquake hazards can help us to become aware and prepared in case it occurs, thus reducing its destructive effects to properties and even our lives. In this episode of Agham Alam Hub, we discussed different earthquake hazards and analyzed their effects. Ground shaking is the vibration that we feel when the energy build-up by the application of stress to the lithosphere is released by faulting during an earthquake. Ground rupture occurs when the earthquake movements along a fault breaks the Earth's surface. Liquefaction occurs when sediment grains are made to float in groundwater, which causes the soil to lose all its solidity. Earthquake-induced landslide is caused by ground shaking due to earthquakes, which destabilizes cliffs and steep slopes. Tsunamis are destructive waves that are generated by earthquakes, landslides, and volcanic eruptions or explosions. We also recognize the natural signs of an impending tsunami. This includes severe ground shaking for a long time, unusual disappearance of water from the seashore, and a loud roaring sound from the ocean. We may not prevent an earthquake from happening, but understanding the different earthquake hazards can help us to become aware and prepared in case it occurs, thus reducing its destructive effects to properties and even our lives. That's all for today, Disciples! Don't forget to like, share, subscribe, and turn on the notification bell. See you again next week for another moment, only here in Agham Alam Hub, Palladian SciTech Portal. Bye!